So let's talk about some various data types that are part of R that we're going to use in our example, and also talk about how we can create our own custom classes. So the first thing that we'll talk about is lists and data frames in R. Now, lists and data frames are really similar to what's called series and data frames that are part of the Pandas API that's part of Python. But essentially what each of these are named entities inside of a list. So if I were to create a list as part of R, essentially I could say, oh, okay, Bob right here is equal to another vector right here of 2, 3, 5. And John is equal to a vector of A and B right here. And so this list that I have right here, if I try to print out V, it's going to say, oh, you have two entries inside of V, Bob and John, and then these are the vectors that are part of each of those inside of the list. Now, if I want to access this variable V right here at the named entity Bob, I can just say V, and then I give the $ operator Bob, and it accesses the memory that's in VBob. I can also access V what right here, so I access kind of something that's not really part of this named part of the list, and I'll get null back, so I won't get anything back. These are really wonderful for creating different tables of data. So the data frame that I'm actually going to do it's actually called rdatas.frame. It's a way of doing something very similar to these lists right here, except each column is going to have a name. So if I were to create these three different vectors right here, 2, 3, 5, A, B, C, and then true, false, true. They're all of different data types from each other, but inside the list, they're all the same data frame, the same data. Well, what I'll do is I'll say, okay, well, I want to create a data.frame of N, S, and B. And what that does is it concatenates all of those together such that the columns are the different names, and each of the rows are given by the number that's associated with the rows. So if I were to create a data frame here, I could access, let's say, N at the S, so NSB. I could access that by saying df at the N in quotation marks, or df at the S, to give me all of the things that are back in this columns that we have right here. So for example, if MT cars is a data frame, I could access it at the 1, 2. Right here, and that would go in and it would access the first column and the second element in there. So 1, 2 is the first column and the second row. I could also name each of these right here. So if the first column was actually named Mazda RX-4 and the row was actually named cylinder, that would actually, I'd be able to really easily go in here and say exactly what it is that I'm accessing. Well, I'm accessing the Mazda RX-4 and the number of cylinders that are associated with each of that. And so this data.frame is a really concise way of representing data where I can name all of the columns and I can name all of the rows. And we're actually going to use that, the data.frame, when we create our different New York Times APIs. So let's talk about classes in R. Classes in R are really, they're a little bit different. S4 classes, there's actually two ways of creating classes in R. The preferred way is to use S4 classes. S4 class creation is the preferred way in R that we're going to do this. And there's a caveat here. Object-oriented programming in R is really extremely awkward. I would say it's really not a strong suit of the language. And in my opinion, it was really thought of after the creation of this programming language for data science. Like, well, we should probably also be using the object-oriented programming, and so let's try to make object-oriented programming fit into what we already have for R, the function creation, how we use R. And so you really should not be happy with the implementation that's in R. It does have a mechanism for using object-oriented programming, but it's different than every other programming language that you will see. And so as a programmer, it should really make you want to cry. But this is how we do it. Let's say we wanted to create a class called article. Well, the way that we would do that is we would call a function called setClass. And inside of that, we would actually tell it what the name of the class is. And we're going to say, oh, well, the name of this class is going to be called article. and it's going to take in a couple of variables. The first one is called data, which will be a list, and the second will be called keys, which will be characters. And so we actually give this a list of the data types that we have right here. So I say a list, well, data will be of type list, keys will be of type character, and I save that into article right here. Okay, so now the class is set, and it's saved inside of a variable called article. But for all practical purposes, we can think of that as the constructor for this class. So immediately we'll be able to call article right here and just open close parentheses and get an instance of the class article. And we can use an equality sign right here. We don't have to use the arrow operator. But if we want to override the initialization function that's part of the class article, we have to do this thing called set method. So what we're going to do here is set method, and we're actually going to call f equals initialize, right? So step one here, we define the class name and its properties. And then step two is we're going to create the initializer if we want to. And essentially, we're going to say, okay, f is equal to initialize. That's the name of the function. Signature means that it's associated with this article class. And then we actually give a definition of the function that we want right here. So dot object is it's like accessing this or accessing self inside of data that we have. So we're going to assume that we've input some data right here, which is a list. Now when I'm going to instantiate all the properties that are part of article, I'll say, well, dot object at data right here. So this is how I access the property, right? So or create a property of the data. So object at data will be equal to data, and object at keys will be equal to all of the names that are associated with data. So data right here, I'm assuming it's a list. And it's like it's basically like a dictionary where I have data and I have names associated with it. So it's key value pairs. So these are the keys, and data itself will hold the values for that. What I'm going to return here is dot object, which is something that I'll always have to do inside of the initialization procedure. And so now if I want to use the article class, I can just say, oh, okay, maybe some article is the text from JSON that we have from New York Times, or it's some, it's whatever it could be. Maybe it's a string, but that's going to get set into object at data, and I'll return an instance of the class A right here. Okay, so now we have a class article which has an initialization function, and it will set object and keys. We'd really like to be able to add different functions and even parameters to this class. So what we're going to do is we're going to create functions. Now, this is one of those things in R which is really unfortunate. But to create a function, the first thing that we have to do is create a global function, which means the function name is going to go into the global namespace that's used in R. So all of the functions that we use in every single class have to be unique. So what we'll do here is we're going to create a generic function, and then we will associate that function with the class that we have. So the first thing we do, I'm just going to set a generic function. That function is going to be called getParam. And the definition of the function is as follows. It's going to take as the first parameter object, and that's kind of generic. We've seen that in Python as well. We always have to pass self in first. And then parameter, it's going to have a default value of type of material right here. And essentially this definition here, this is a standard generic function with the name getParam, right? So all of this right here, all it really does is define a global function called getParam, which is a standard generic function, and it has the type where the two data types that enter into it are firstly the object and some type of parameter. So now when we want to associate that, let's define what this function does, right? So this is just the prototype for the function. Now let's define what the function does. Here's where we say set method. So now it'll grab that generic method, which we defined up here as getParam. the signature is associated with article, so associate this method with the article class. And now we'll write the definition of the function. So the function takes an object and parameters. The object is always the instance that we're passing in. So what I can say is if param is in the object keys, return object at the data at the param right here. And so what we'll do is basically this syntax right here that we have is I'm going to access data at the param right here, whatever the param value is. So these little extra braces right here tell it that data needs to be accessed at the param, and that's kind of a very R-specific syntax, but we'll go over that more as we do. If that was not inside there, I'm just going to return an empty list, right? And so now I can call class methods, but it doesn't automatically provide the instance to the class. So essentially I'll create A at the article, right? So some article, I'll initialize A, and I'll say get the parameter, and I'll pass in A. I have to pass in the instance of the class, and then the parameter, which is lead paragraph right here. So that would actually go in there and would access object at the data, the dictionary of data that I have, and it would grab the lead paragraph and return to me the string. And that would be the output of get param right here, right? So this is a really convoluted way of defining classes, but it does, allow you to do object-oriented programming using S4 classes. It also allows you to do things like inheritance that we've seen before. So if I create a new class, right? So if I create this article with media class that we have, well, I'm going to call it article with media. I'm going to tell it, what the parameters are that this, it's the same thing as it's got list, characters, and now it's got a list of media that'll be associated with it. Well, it's also I'm going to put this last little thing, contains article, which means this article will be a superclass of article with media, assuming that article has already been defined right here, right? So I define a subclass of article called article with media, and it's contained inside of this article class, right? So article is superclass. And now I can initialize my inherited class in this way, because when I inherit from something, I want to be able to call the initialization function for that original class. The way that I do that in R is set method. We're going to be looking at the initialization method for the article with media class, so that's exactly the same as before. The function that we get is we pass in the object and some data vector that we have right here. And now I'm going to say, okay, well, object at the media right here that we've defined, that's going to be a list of length data at the multimedia right here. So I say, okay, well, whatever multimedia was, however long that is, create a new vector and save it in object.media. And then I can do some things with it for each element in that. But at the very end of this, what I really want to do here is I want to say call next method object data. And what that does is it says, okay, initialize what you need to do here, and then call the next initialization function, whatever I have inherited from. It'll call the superclass of article, and it'll hand off data. That happens right there. You have absolutely no control over the hierarchy of initialization. So this is not a real programming language, in my opinion, because we can't control this call next method. If we inherit from multiple different classes, we have no control over this right here, which method gets called first, or if we call certain initialization procedures, right? So there's not a whole lot of control when we're using inheritance in R, but it does exist, so I wanted to talk about it. So let's put the whole thing together and start to use S4 classes and build up our New York Times data scrubbing in R.